Friends, here is the second programming challenge. You will find just one problem in this challenge, but believe me, this problem would be sufficient to clear up all your concepts related to data types and its casting issues. If you have already seen the rules earlier, please skip this video for about a minute to reach the problem description scene. Please go through these rules before you take this challenge. Please take a notebook and pen before you read further. Problem shown here will also depict a recommended time to solve with the acronym shown as RTS. You are advised to keep it as a guideline for you. Don't worry much if you take higher time than the recommended time. Efficiency increases by practice only. Right? You are requested to pause the video after the problem is shown to you. If you really want to evaluate yourself, please do so. After some time of the problem slide, you will be shown the hint slide. You should play the video further to watch the hint and then pause again to try solving the problem again. After that, you are brought to the detailed solution page. Please watch every second of it and compare it with your own solution. Watch this Java code carefully, follow each step one by one, and then write down what would be the output of this program. Please pause the video now and try to solve the problem. Play it further when you need the hint. Lower size data type to higher size data type is usually valid while casting. Pause again now. Replay further when you are ready with the answer. Here is the detailed solution. Let me explain you how data type conversion is done. This is a program depicting data type conversions between int, long, char, float, double, etc. So let us see each one of them. So this is a simple class and there is a main function where first one is integer n is equal to 1 has been declared, where n has been put into ln a long variable, and then printing of this long has been done, and similarly one by one things have been done. Let me show you the output and then explain each of them. See, here I am running the project. This I am using the NetBeans integrated development environment, and this project output window is here. Let me make it little smaller so that we can see both the things clearly. I will place it here. Okay. So here this, since long can easily contain integer because this is long integer, so I can directly put n to ln and the print value is same. This is the output here. Then this I am printing character C into ln, the long variable. So since character C is 99 ASCII code, so this gets printed as 99. Okay, because here I am directly transferring C to a integer variable. Now again, we are casting an integer variable as a character. This is character casting. Now after character casting, this become a character, and now if I am printing C1, just see it is getting printed as C as a character, as the alphabet small c. Now simply just see this casting to integer, a float casting to integer. This is a f is a float variable. We have initialized it to 3.2. Since we are casting it as int, so the decimal portion will go off and it will just remain 3. So we are printing this n as 3 now. Now again we are casting this float as integer and transferring it to double variable. And now we are casting it as character and then transferring it to D1. Let us see what happens. See, in this case, this f is 3.2, But since I am casting it to int, but transferring it to double, so it displays as 3.0. Okay. And this f is still 3.2. The character casting will not make any effect because you can't have character as 3. So it will show you 3.0 because I am still showing it, putting it in double variable. So this is displayed as D1. And then simply showing f as directly, so 3.2 gets displayed here. So this line is coming using this system out.println. Now the interesting thing happens when float to double type conversion is done. Ideally, double is much larger than float, but there is a difference. Let us see what happens. When 3.2 was getting printed as double, it gets some equivalent value printed. 3.2, then 0000000 47683716. This is due to, see, this is explained well by converting it to binary strings, both of them to binary strings. And this is the binary version. This actually, you will be able to see that there is a shifting of binary data between float to double, because double has to be really very long, and the figures in mantissa and exponent portion in float and double calculations are different. That's why float to double calculation, although double retains higher precision, but the final value may look little different. Okay, so these are all types of data type conversions. Thank you.